Hello everybody. Today we're going to talk about the first problem in a binary search. Okay, so what is binary search? Binary search is a technique of searching a particular target element in your sorted sequence, right? And the time complexity of this is log of n, the worst case time complexity. If you do not know what binary search is, please check out my earlier video. It will be linked somewhere down. Now, in binary search, once you understand what binary search is, the next phase in your learning is to be able to apply this technique to solve your problems, which is what we called as problem solving skills. In binary search, there are mainly two patterns which get asked. One is a standard modification of your actual binary search, right? The binary search where you do low and high, where your low is nothing but the first element of the array. That's why the index is 0, and high is usually the last element of the array, which is n minus 1. You try to find a mid, you compare your target value with the mid, and you try to keep on doing this process until you either find the target, or else you exhaust all the array elements, right? Exhaust all the array elements means all the array elements are over and yet you're not able to find that particular target. Okay, so that is your standard binary search, right? So the slight variation in that algorithm, okay, kind of such questions which are based on that is your first pattern in binary search. Second pattern in binary search is binary search, which is applied on the answer space, right? We will talk about this in the next video. For today's video, what we are going to do is we are going to solve our first question in the first pattern, right? The name of the question is basically find the first and the last position of an element in an array. Okay, this is a very standard question asked in a lot of interviews. Let's try to understand this question. This question is again available on Geeks for Geeks, on Leetcode, and different platforms. Here I have Leetcode. So you can see find first and last position of an element in a sorted array, right? So if you remember that binary search can be applied if the array or the array list is in sorted order. So the question says, given an array of integers, the array of integers is nums, sorted in non-decreasing order, find the first and the ending position. Okay, find the starting and the ending position of the given target value. If the target is not found in the array, you need to return again a one-dimensional array saying -1 indicating that the target was not found. You must write an algorithm with a time complexity of log n. So obviously the hint is there in the question, right? So whenever you see any question in which this line is mentioned, that the algorithm which you need to come up with needs to be log of n, you need to that thing should strike in your mind is that this question can be solved using binary search, because binary search is one of the most famous way of solving question where the solution can be obtained in logarithmic time, or in other words in O of log n time. Okay, so once, if you see, this is a medium level question asked in a lot of interviews, right? So once you understand this question, right, this is a pattern of question, you can try and solve similar questions, like for example finding the seal or the floor of a number in your in a sorted sequence. Yes, yeah, for finding something like this, right, finding the target indices after sorting array. Can you see the similar questions? All the similar questions and plenty more could be solved once you understand this concept. So let's try to solve this question using binary search. Let's try to understand the question. The first part of the question is to find the first first appearance, the first index at which the element is appearing, and then is the next part is to find the last index of that element. What does this mean? So suppose if you have a sorted array, because the question has mentioned to us that they are going to give you a sorted array. Okay, so the sorted array looks like this. Suppose 5 7 7 8 8 1 2 3 4, and then you have 10. So let's try the indices here: 0 1 2 3 4 5 6 7. Just a reminder that in programming your index always starts with 0. If you want to understand why an array index starts with 0, you can check out my reel where I have explained the why a particular index always starts with 0. Okay, so this is a sorted array. Yes, the question had mentioned a sorted array, and we are supposed to find out the first and the last index. Suppose the target element is given as 8. So the first index at which 8 appears in the array is 3, and the last index at which the 8 appears is 6. Okay, and we can always be sure that whichever target we are looking at, right? They are going to be like, suppose if 8 is there, this 8 is going to be, if there are like more than one appearance or more than one occurrence of this 8 in our array, it's always going to be one after the other. Like, so if you see there are 4 8s and they are one after the other. Why? Because it is a sorted array. Okay. Now, second thing is they have said, suppose if you get a target value as say 9, right? Do we have any 9 present in our array? No. So then your answer is going to be the first index, so at which this 9 appears is going to be -1 because the 9 is not present, and also the last index is going to be -1. So this is what is asked for about on us. All right. So to solve this question, let's try to break down this entire problem statement into two parts. The first part is where you try to find out the first occurrence of a target, and the second part would be to find out the last occurrence of the target. Okay. Once you understand this, it will be very easy. In fact, most of you will be able to come up with the solution to the second part. Okay. So let's start with the explanation for the first one. Because it is a sorted array and the question has mentioned that you need to provide the solution in a logarithmic time. Log of n is usually called logarithmic time complexity. We can be sure that we have to use binary search. Again, the second clue to use binary search is that you are given a sorted array. Whenever in any question, guys, you have these two things given, be sure that the question will be solved 99% of the time by using binary search. Okay. So here, let's try to see. Suppose we find out the mid. So because a typical binary search looks like this, you say low index number 0, your high is pointing to index number 7. So low plus, to find out the mid, what will be 0 plus 7 by 2, right? Sorry, this is 0, 1, 2, 3, 4, 5, 6, 7. Let's add one more 8 here. So let's make this 7, let's make this 8. So you'll have 0 plus 8 by 2, and that is nothing but 4. Okay, I just added one more 8 here. I'll tell you why I did that, just to explain this concept of this particular first part of the problem. At 4, that is your A of mid, and let's assume the target we are currently looking at is target equal to 9. So that means we need to find out the first index and the last index. So because we changed this, the last index should come as 7. Okay, so A of mid is equal to what? Our target value, which is equal to 8. Yes. Suppose, let's say we are trying to find out the first occurrence, right, of this target value. What would you ideally do? Suppose if your A of mid is equal to the target value, and if you know this is 8, so you will want to search in which direction? You will try to say, okay, at my mid value, I have the target element. That means I have at least found the, that I at least know that this target exists in my array, correct? Second thing is, if you are wanting to find out the first occurrence, because this array is sorted in ascending order, if this is not the first occurrence, right? The first occurrence of that 8, okay, first occurrence means the first time that 8 value comes in our array will be to the left of this. Are you getting what I'm saying? I'm saying we are trying to solve the part where we're trying to find out the index at which the target value is appearing for the first time in the array. For 8 target, the value is index equal to 3. As you can see, because this 8 is coming for the first time at index number 3. Now I'm trying to apply simple binary search, which we know. If you do binary search, the first is you find out the middle element. Middle is 0 plus 8 by 2, which is going to give me 4. A of mid is the value 8, which is equal to target. Now, can you be sure at this moment that this is going to be the first occurrence of this value 8? No, it can be a possibility, right? At this point, when you get this value, there are two possibilities. One possibility is that this index mid is the first occurrence of your target value, correct? Or else the second possibility is that it is not the first occurrence. If it is not the first occurrence, then the first occurrence and the first appearance of this target value is obviously to the right, to the left of 8. Yes, to the left of 8. Yeah, why? Because we are sorted in ascending order. So to the left of your mid will be basically you have to search. So in our binary search, what we do, we usually choose either this part to search, or else we search in this part, right? So if you're doing the first occurrence and if you find your target value at the mid, what you need to do is you will have to you have these two situations, right? Now to take care of which situation, the first situation, which is this, This can also be a possibility. Okay. So let's say we define a variable int result. If this is the variable where we are going to store a final value. Final value of what? The index at which 8 is going to appear for the first time. Okay. So whenever you get a of mid equal to 8, can't we say that the possible answer for this result is mid? Okay. We do this, but we do not stop here. That means stop here, matlab, I'm not going to directly say return here. No, that's not what I'm going to do. Why? Because getting a value, target value at the mids basically opens up two possibilities, right? If it opens up two possibilities, I've taken care of this possibility by saying ki, okay, the possible answer can be at the index mid. So I'm storing that value. Okay, so I'm taking care of that possibility. And let's say if this is not my answer, I have to keep on searching further just to be sure that is there any 8 which has appeared before index number 4. How will you do that? By suppose your low and high is here. Now you have to search in which half? This half. This half means the left hand side of the half means your high is now going to be what? Mid minus 1. You get my point? So I'm going to say here high equal to mid minus 1 because now you're going to search in this part of your array. Is this understood? Let's go through over it again. We are trying to find out the index at which 8 appears for the first time in my array. According as you can see in this array, it appears at index number 3. Okay, so let's say the variable in which we'll store the value of the index at which 8 is going to appear for the first time. Let's take a variable as result. Okay, you can take its answer, anything. What we're going to do is whenever you find the target value at mid, there are two possibilities. One possibility is that this is my first occurrence of 8, right? Okay, it can be, right? It can be possible that this, if in case, in another example, if this 8 was not there, so your number 4 is going to be your answer. Correct. So we said that it can be a possibility that mid is the first, is the first occurrence of 8 and therefore the answer would be index 4. How are we going to store this value? By storing into result equal to mid. And to explore second possibility, we also have to keep on searching towards the left of 8 just to be sure that whether 8, if it's appearing more than before this value, if 8 has come up again, then we need that index, right? So that's why we're going to search in this part. And when you search in the left hand part means your value of high is going to become what? Mid minus 1. I hope you get this, right? Next, what are the other possibility possible? So let's change the color here. Take the black color. So see, first was that if a of mid equal to target, which we saw. There are 3 more possibilities, right? We have learned binary search. So the another possibility will be that a of mid can be greater than target, and the last possibility will be a of mid being less than the target value. Okay. Think about this. You are trying to find out the first occurrence or the first appearance of the target value. If your a of mid value is greater than target, if a of mid value is greater than target, what are you going to do? Suppose you are saying this is your mid. Whatever value you are finding, suppose this value is 10. Suppose, let's take an example. And the target value is 8. If your a of mid is 10, it's greater than target. Where you are going to search? In this part. Correct? Because these are the values less than or equal to 10. What does that mean? Changing your high equal to mid minus 1. This is exactly you do when you are trying to do a standard binary search. Am I right? Yes. What is our next possibility? If a of mid is less than the target. So let's assume the target value is 8 and your mid value here is suppose a value which is stored at mid, and let's say it's 4. So now a of mid is nothing but the value 4. This value is less than 8. If it is less than 8, where are you going to try to find your target? In this part. In this half, the right half means your low should become mid plus 1. Isn't this exactly what we do in a standard binary search? Yes. What has changed from the standard binary search in this solution? The only change you do is when your a of mid value is equal to target. Let's tidy this up a bit. So whenever your a of mid value, right, is equal to target, usually what we did in the standard algorithm, returned the index. But here we cannot do that. Why? Because here we are interested to find out the index at which that target element appears for the first time. Okay, so we can have two possibilities. Either that target whatever is the mid index, that is at which it is appearing for the first time, or it is possible that it has appeared before it, as we have this scenario here, right? We found at mid the value 8, but it is possible, and we can see that this 8 has appeared before 4 as well. How will you get this? By moving your search in this direction. Okay, because we are trying to find the first appearance. I hope this is clear. Yes. Now just think for some time. What we did in this question is nothing but apply binary search. The same reasoning, same logic. Depending upon what was asked to us, we just made change only in this part, in this if condition where your if A of mid equal to target. Am I understood? So this is a pattern of question which you usually get asked in binary search, where you just making small modifications in your standard binary search algorithm. Okay, let's try to look at the code for only this part. You can see I have written, so I've written a function FBS, which is basically means finding the first occurrence for a particular target. I have low and high. Obviously when I call them, I'm going to call it 0 and the find last index of my array. To get the last index, I can say nums.length minus 1. Okay, this all remains same. If you remember, while low is less than or equal to high is exactly what we do in a standard binary search as well. Yes, so if you see here, what I've done is I need to have this result f, right? So where I had mentioned I need to have some variable where I'll store a value, right? So that I have as result f. If you see this result f value, it's been defined here in this function as -1. Why -1? Because if I do not get the target value, obviously I need to send -1. That is what mentioned to me in the question. What does -1 mean? It actually means, it signifies that that particular target is not being found in the array. And we have discussed this at length in a previous video. If you have not checked that out, please check that out. So you're going to find out the middle value. Yes, I hope by now everybody understands how to find the middle value, low plus high minus low by 2, just to avoid overflow. If your nums of mid, now the name of the array is nums, so the nums of mid is equal to target, and you're trying to find out the first occurrence, right, of the target value, you're going to say okay, mid can be a possible answer, and you're going to try to search in the left half, right? So you're going to do high equal to mid minus 1. Else if there are 3 possibilities, right? Either the value is equal to target or the value is greater than target. If the value of mid is greater than target, yet you're going to check in the left half of the side, right? So high equal to mid minus 1. Else, what is the else part? When your nums of mid, the mid value, whatever value is present at mid, if it is less than target, then obviously you're going to check in the right hand side of the array. So low equal to mid plus 1. You're going to continue to do this until your while is less than or equal to high, correct? After that, you can simply return the value, whatever is present at result of f. Yes, I hope you understood this, right? Now let's try to, apply that algorithm for this array, right? So let's take a fresh page. Let's try the same array which we were looking at. So 5, 7, 7. We have 8, 8, 8. So we have 0, 1, 2, 3, 4, 5, 6. All right. And we have 7, one more 8. And then let's say 10. Which is 8. So first is low and high, right? You find out the mid value, which is going to be 0 plus 8 by 2, which is equal to what? 8 by 2, which is 4. So we check A of mid. Is it equal to a target value is 8? Okay. So is A of mid equal to 8? Yes, because A of 4 is equal to mid. So what you're going to do is we're going to store in a result value, result of f, the mid index, which is 4. Okay, and go to what? You're going to say high equal to mid minus 1. What does this mean? We are trying to discard this part of the array, and now our search space is only this, from 5, 7, 7 to 8. Right? So what we're going to have is now our search space, low is equal to 0, and what is your high? Mid minus 1 means it is equal to 3. So let me just write the 0 to 3 array. 0 to 3 array was 5, 7, 7. So 0, 1, 2. And 3 was nothing but 8. So this is low, this is high. Okay. Again, you find out the mid. 0 plus 3 by 2, right? So 2 ones are 2, 3 by 2. So mid is basically 1. What are we going to have here? A of mid. Is it equal to 8? What is A of mid? A of 1 is 7. Is 7 equal to 8? No. What do we have to check? 7 value is less than 8. If 7 value is less than 8, what should I do? I need to make sure to search in which part? In this part of my array. So what should my look like low equal to mid plus 1. So what is mid? Mid is nothing but, I think the value is 1. So 1 plus 1 is nothing but 2. So your low is equal to 2 and your high is equal to 3. So what do we have? 2 to 3 we have 7 and 8. Okay. Find out the mid. That would be 2 plus 3 by 2, which is 5 by 2. So 2 2s are 4. We are doing integer division. So 2 2s are 4. So you have what? 2 here. So this is what your, again, your mid, right? So if this is also low and this is also your high. So your low and high, right? So what about this? Is 7 greater than or less than, what is it? It is less than 8. If it is less than 8, what you're going to do? Your low becomes mid plus 1. What is mid plus 1? 2 plus 1, which is equal to 3. So what you have is your low is pointing to 3. Your high is also pointing to 3. Right? Remember, your while condition is while low is less than or equal to high. If both are same, obviously your mid value is the same index. You're going to check a of 3 equal to 8. Is a of 3 equal to 8? Yes. At index number 3, we have 8. So 8 is equal to 8. We're going to say result of f going to give a value of 3. Right? You are going to rewrite the value. Now, because you rewrite, what you're going to do? You're going to try to see if there's any 8 before this index. That means you're going to say high equal to mid minus 1. Mid minus 1 is 2, right? So your low is pointing to 3, high is pointing to 2. It does not satisfy this, condition that low needs to be less than or equal to high. And that's why your while loop gets terminated. Finally, you're going to return value what? Return the value of result f, which has an index of 3. Look at the entire array which we started with. This was our array. At index number 3, we have the first occurrence of 8. And that's what we also got in our value. Result f had a value of 3. Yes, what we did? Simple standard binary search with only one twist, which was here. Okay, just need to understand the entire gist of this question solved. I mean, the solution is that because you are supposed to find out the first occurrence of that element, of that target. If you happen to see that target, you try to go to the left of it and see, okay, have I got any more appearance before this particular index? That's what we are doing. That's why you're doing high equal to mid minus 1. How much time it will take? Again, equal to your log of n, because it is a simple binary search with a slight change. Yes, I hope you understood the first occurrence of an element in a binary search. Yes, for some reason, if that target was not found, what is going to happen is you are in this while loop, right? You will never be able to satisfy this condition, right? Because the target value was not present. So what you're going to return after you finish your while loop, you're going to return the result of f. In the question, they have mentioned that if the target is not found, you should return a value of -1. So you see, that's why we have, initialized the value of, those variables as -1. Right? Okay. Now let's look at the second part of the problem, which is to find out the last occurrence of our target value. Continuing the same example, if you have the same array, our target value is 8. We found out the first occurrence of 8, which was at index number 3. Last occurrence is where? At index number 7. Right? So what we did to solve the first part was, like, when we wanted to find out the first occurrence of 8, whenever we found the value 8, we tried to go where? We tried to go to the left of 8, right? Why? Because there is where we can find the first occurrence, right? If there is, any more 8s, right? Now, when you try to find out the last occurrence, where would you go? You would go to the right hand side. Right? You would go to the right hand side of 8. So when you want to find out the first occurrence, you go to the left hand side. When you want to find out the last occurrence, you're going to go to the right hand side, right? Why? Because the last occurrence of 8 is at index number 7, right? So that means you have to search in this part of the array. I hope this makes sense, right? So let's try to debug this question for this particular array and you will understand better. So as usual, we have low at pointing to the first index and your high pointing to the last index. So you're going to find out the mid as 0 plus 8 by 2, which is equal to 4. So we see our a of 4 is equal to target value, which is 8. What we're going to do is here we're going to have one more variable, result of L, which is going to store the possible index for the last occurrence of 8. So here we'll have result of L equal to 4. Why? Because similar to our last part, whenever you find that target value, you have two possibilities. One possibility is that this actually, the middle value, I mean the middle index is actually the last occurrence of your target value. Or else the second possibility is that there is one more 8, one or two multiple 8s after this index. To search that, we have to search in the right hand side of 8. To do that, what you're going to do is your low should become mid plus 1. Why? Because now you're going to search in this part of your array. Okay, so that's what we exactly did. So because of this, now your low value is going to become what? Mid plus 1 becomes 5. Your high value is pointing to index number 8. Let's just write this part of our array down where you have 3 8s followed by 10. So 5, 6, 7, 8. This is your low, this is your high. Again, mid will be what? 5 plus 8 divided by 2, which is nothing but 13 by 2, which you get 6 by integer division. What is there at a of 6? At a of 6, we have 8, right? Which is our target value. So what will you do? Again, we have two possibilities. So let's say that this can be the last occurrence. So we are going to, actually last occurrence, result of L, we are going to say equal to 6, the index, right? And just to make sure this is a last index, what we have to do, we have to go to the right of it and check if we do not have any more occurrences of 8. So we're going to do what? Low becomes mid plus 1. If mid is basically 6, this becomes 7. So now what you have is low is pointing to 7 and your high is still pointing to 8. 7 to 8, your array looks like 8 and 10, right? I'm just copying these parts, 7 and 8. So this is my index in this. Again, find out the mid. What your mid will be? 7 plus 8 by 2. That is nothing but 15 by 2. Right? So I hope you are understanding what we are doing, right? We were initially doing this is where you started, correct? So 0 and 8, you got your middle value. Middle value was 8, which is equal to target. So we went to low equal to mid plus 1, correct? So we had this mid value was 4, correct? So we did low equal to 5 and high equal to 8. So 5 plus 8 gave us a mid value at 6. At a of 6, we again got 8, which was a target value. So we said, as you can see here, a of 6 equal to target value. So we said low equal to mid plus 1. Mid was what? Pointing to 6. So mid plus 1 is going to give you what? 7. 7 is here and 8, which is your high index. 7 plus 8 is going to divide by 2 is 15 by 2, which is nothing but going to give you 7, right? So now your a of 7 is nothing but what? 8. Again, it's a target value. So you're going to say result of f. This result of L, your last possibility, can be this index as well, which is your index number 7, your mid value. And you're going to try to search to the right hand side of this. So right hand side is mid plus 1, which is nothing but 7 plus 1, which is equal to 8. So now you have low at index 8 and your high is also at index 8. That means you have the last element, which is 10. Both are pointing to the same thing. Mid value is also 8. Now is a of mid, this a of mid is greater than our target value, because 10 is greater than our target value. If it is greater, what you do is you have to try to search to the left hand side of 10. Left hand side means your I becomes equal to your mid minus 1. If I is mid minus 1, this is nothing but 8 minus 1, which is equal to 7. What it looks like is low is equal to 8 and high is equal to 7. Now this does not satisfy a condition that low needs to be less than or equal to high, right? That's why your while loop gets terminated. What is the value which is stored in the result, which is 7? Is 7 the last occurrence of our 8, the target value? Yes. Did we get our answer? Yes. So here we got result of last is going to have 7. Result of first, which is storing the first occurrence of the target value, which was equal to 3, which we had seen earlier. I hope this makes sense, right? So simple binary search, just you need to twist one condition depending upon problem. It's a very simple logical question. Let's just look at the code quickly. Here everything remains the same, right? Your while loop, you're finding the mid thing, right? Only here I'm making a change because you're trying to find out the last occurrence. So whenever the middle value at the array is equal to my target, I'm going to say that this can be my possible answer, where this is my last occurrence of the target value. And the second possibility, just to make sure that this is the last occurrence, I'm going to go ahead and search into the right of my target value. So I'm doing low equal to mid plus 1, right? If a particular value at the mid, if it is greater than target, obviously if the value is greater than target means you have to search to the left of the target. So high equal to mid minus 1. Else this is going to get activated whenever your middle value is actually what? It is going to be lesser than target. If it's lesser than target means you have to search to the right of the middle value. So low becomes equal to mid plus 1. Keep on doing this. If you're able to find your element, so obviously you'll have a correct value in your result which you're going to return, right? For some instances, target was not present in the array, then as you know from the earlier example as well, what we did was we have initialized both the first occurrence and the last occurrence as -1, because that's what the question has mentioned to us, that if the target does not exist, we have to give -1. Now, the way the question wants us to answer is, if you can look at it, they want you to answer in the form of a one-dimensional array. How do you understand that is, suppose if it's difficult for you to understand the question, always try to go to the sample input and output, from where you can understand the question and the way they want you to, provide the output, it becomes very clear. Right? So suppose you can see in the input they have given us, this is your input, the target value. They want your output in the form of a one-dimensional array. Correct? The 3 is the first occurrence of the index, and I mean of the target, and 4 is the last occurrence of the target. If you look here, and they have also, given that you have to return a one-dimensional array. So what we have done is, I think this is visible. Simply I have created an array, right? So I'm called a function. This function is going to take care of the first occurrence, and this function is going to return me the last occurrence, right? Which we just saw in our IntelliJ, right? Same code, result of 0, the first, just put it into a one-dimensional array and return, right? If you just submit this code is going to work fine. Yeah, and you can find this code on IntelliJ on my GitHub. I will put this code on GitHub, and the name of the code will be the name of the question as well. I'll also link, the Leetcode link here. It's free of cost. So if you want to practice this question, you can definitely do so. This is a very important question. If you understand this question, trust me, your one pattern, on this particular concept, you can have around 10 to 12 questions. You will be able to solve most of them, right? So how to go ahead from here is, once you understand this particular tutorial, try to solve similar questions. Okay, see if you're able to understand it, correct? And I hope this helped. Let's just talk about the time complexity for this question. As you can see from the solution, that we have two function calls here. One function call is going to return us the first occurrence of the target, and the second function call is going to return the last occurrence. Both of the functions are actually variations of a standard binary search, right? So the first function which we have is going to have a time complexity of, worst case, O of log n, and the second function call is going to have a time complexity of O of log n. So we have two function calls having each log n. So we can say it is O of 2 into log n. So as you know, in asymptotic notations, right, in time complexity, we ignore the constants. So this is actually equivalent to O of log n. And so that's why we can say that the entire solution has been done in a logarithmic time, which is what is required for this question, right? I hope this helps. If you have understood this question, please give this video a thumbs up. It helps me and the algorithm. And just share, like, and subscribe the channel. Bye. Take care.